Hi everyone. So today I'm going to discuss with you about the quadratic relationship. So let's suppose we have a house and this is the top view of the house, and surrounding the house we have like a grass area, and we want to create like a small garden at the back of the house. So this is at the back of the house. So we want to create a small garden. It's a rectangle, and we want to make a fence like this. So we start from this point and then we go here, here, and then there. So you will have an rectangle area of the garden. Now the total length of this fence, for example, it's made of wire, and the total length of this fence it's 16 meters. Now the question is, calculate the largest area of this garden. Right. Now, when we want to answer the question like this, I think the first thing that we need to find out, the first thing that we need to think about is the mathematical model. And this is a good example of a problem that gives us a mathematical model. So basically we will start with something that we know. For example, you see the area here, it's a rectangle, and we know if we have a rectangle, therefore the area will be the length times the width. Now, so we are given a constraint, in this case the total length of the wire, the total length of the fence, it is 16 meters. And if we look at this diagram, this is the width, this is the length, and also another width. So be careful, because this side is not covered by the wire because it's at the back, the wall of the house. Okay. Now the constraint that we have here will be this 16 meters equal to the width times the length plus the length plus another the width of the garden, or 16 equals to 2 times the width plus the length. And if we try to express now the area in terms of, say, one of these, in terms of, either the length or, say, the width, we can substitute one of these. So for example, we want to express the area in terms of the width. In that case, we have to substitute whatever the length is from this equation. So for example, from this equation, we got that the length equals to 16 minus 2 times the width. And then we can plug it in here. So with the length now is equal to 16 minus 2 times the width, we can get the general mathematical model of the area in terms of the width, which is 16 times the width minus, now we have 2 times the width squared. Right. Now if you look at this expression, we have a quadratic relationship between the area and the width. And this is actually interesting because in the previous lesson, we have learned also, but it's not quadratic. It was a linear relationship. So in this case, if you have this kind of equation, for example, y equals to mx plus c, or for example, y equals to 2x plus 1, and then you try to plot this equation, what you will see is a straight line, right? And with the quadratic relationship like this one now between the area and the w, the width, we will not see a straight line like this, right? So how is the graph of this quadratic relationship that we will get from this mathematical model? Well, we can now create sort of a table and, you know, insert the numbers in there. So for example, if I have the values of the width and this is the values for the area, now we can start from, say, the width equal to 0. So when the width equal to 0, you see, when you calculate that number, 16 times 0 minus 2 times 0 square, that will give us also 0. Of course, the area will be 0. Now, when the width equal to 1, for example, it will be 16 times 1 minus 2 times 1 square. So it will be 14. And then we can continue. For example, when the width equals to 2, 16 times 2 minus 2 times 2 square. So 32 minus 8, yeah, this 24. And then when the width equal to 3, 16 times 3 minus 2 times 3 square. So it will be 48 minus 18, and that gives us 30. So let's continue. When the width equal to 4, so it is 16 times 4 minus 2 times 4 square, 64 minus 32, which is 32. And then next one, when the width equal to 5 meters, 16 times 5 minus 2 times 5 square, so 80 minus 50, we got another 30. And then when the width equals to 6, 16 times 6 minus 2 times 3, 6 square, so it will be 96 minus 72, it is 24. And then when the width equal to 7, 16 times 7 minus 2 times 7 square, so what is 16 times 7? That is 112, right? And then minus 98. So give me 14. And then lastly, when the width equal to 8, 16 times 8 minus 2 times 8 square. So, well, actually, if you calculate this number, it will give you 0. Now, based on this table, we can now make a graph of this quadratic relationship. So, for example, we have now a, graph of the value of the width and the area. Yes. So let me now zoom up a bit. When the width equal to 0, okay, let me see the biggest value that I got here, 32. Okay, so that means I can put like this, 10, 20, 30, and this is the width, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Now let's start with the first one. When the width value equal to 0, that gives me an area equal to 0. So the point of that number will be here. And then when the width equal to 1, gives us the area equals to 14. So it is somewhere here. And let's continue. When the width equal to 2, the area is 24. Somewhere here. And then next, when the width equal to 3, the area is 30. And then when the width equal to 4, the area is 32, and so on. So you see, when you try to get these points, what you will get, they are doing like this. And then at the end, when we connect these points here, like using this curve, oh, sorry. So, well, let me try to connect them. So what you see here is that the quadratic relationship that we had before, where the area equals to, 16 times the width minus 2 times the width squared. The graph that we got here is no longer a straight line. So it's a bending curve like this, and it's called a parabolic curve. So that is the kind of the curve that we will get from a quadratic relationship like this one, yeah? And when you look at the original question here, calculate the largest area, what we need to find here is the biggest number of the area that you can get, which is this point. And that is this number, 32. So actually the most important idea here is just the introduction of a quadratic relationship, and in the future we will explore this further, and also we will call this as a quadratic function. So now you see the difference between the linear relationship that we did before and now the quadratic relationship that we are doing, which give us the curve named parabolic curve. And we will explore further this one later in the next video. Thank you.